Hi, this is Miss Barber. The title of this lesson is Polar Coordinates. The learning objectives for this lesson are: 1. Know the definition of polar coordinates. 2. Be able to express polar coordinates as rectangular coordinates and vice versa. 3. Be able to convert a rectangular equation to a polar equation and vice versa. Roman numeral 1. Definition of polar coordinates. The polar coordinate system uses distances and directions to specify the location of a point in the plane. To set up the system, we choose a fixed point O in the plane called the pole or origin and draw from O a ray, a half line called the polar axis. Then each point P can be assigned polar coordinates P, r, theta, where r is the distance from O to P, and theta is the angle between the polar axis and the segment OP. We use the convention that theta is positive if measured in a counterclockwise direction from the polar axis and negative if measured in the clockwise direction. If r is negative, then the point r, theta is defined to be the point that lies the absolute value of r units from the pole in the direction opposite to that given by theta. Because the angles theta plus 2 pi n, where n is an integer, all have the same terminal side as angle theta, each point in the plane has infinitely many representations in polar coordinates. Plot the point that has the given polar coordinates. A, 3, pi over 4. I begin by making a dot that represents the pole and drawing my polar axis. Now remember, polar coordinates are determined by direction and distance, so I will move in the counterclockwise direction pi over 4 units, then draw a segment that is 1, 2, 3 units long. So this point is 3, pi over 4. Let's do this for part B. 3, negative 7 pi over 6. I will begin by drawing the pole and my polar axis. The negative 7 pi over 6 tells me I go in the clockwise direction, so I will go in the clockwise direction or backwards, negative 7 pi over 6 radians. Then I will draw my segment in the positive 1, 2, 3 units. The point that has the negative 7 pi over 6 and a height of 3 is 3, negative 7 pi over 6. For the point 3, pi over 4, give two other polar coordinate representations of the point, one for the radius less than 0 and the other for radius greater than 0. Let's look at the point we plotted for the previous example, which was 3, pi over 4. For r that is positive, all we need to do is go around one more time. That is, from our point, just add 2 pi. And so for r positive, we can have 3, pi over 4 plus 2 pi, getting a common denominator. For the 2 pi, that'll be 8 pi over 4. That sum would be 9 pi over 4. Now, for the requirement that the radius is negative, I'll begin by drawing a negative radius of 3 that is going back 3 units. And remember, we still want to end up at the same point, we want the same terminal side that we got with 3 comma pi over 4. Notice that with -3 we are diametrically opposite, so we can start at -3 and do pi over 4 and either add or subtract pi. I prefer to add to get us back to where we were. And so we'd have -3 and then pi over 4 plus pi. That would be 4 pi over 4. So with the common denominator, we would get 5 pi over 4. Roman numeral 2, relationship between polar and rectangular coordinates. To change from polar to rectangular coordinates, use the formulas. X equals r cosine theta and y equals r sine theta. To change from rectangular to polar coordinates, use the formulas r squared equals x squared plus y squared and tan theta equals y over x, provided that x does not equal 0. Find the rectangular coordinates for the point that has the polar coordinates 6 comma 2 pi over 3. The formulas we have are to find the x, that's equal to r times cosine theta, and to find the y, that's equal to r times sine theta. But before we actually find the coordinates in rectangular coordinates, let's place where this point would occur. So I'll start with my polar axis. We're going to go 2 pi over 3, so that would put us in the second quadrant, and the length will be 6. So we got 6 and 2 pi over 3. This is a check to make sure that the points we get also put us in the second quadrant. So for x equals r cosine theta, it would be 6 times the cosine of 2 pi over 3, which is 6 times, and the cosine of 2 pi over 3 is -1/2. So we get -3 for the x value of the ordered pair. Now let's do this for the y. Y equals r sine theta, so y equals r, which is 6 times the sine of 2 pi over 3. So we're going to have 6 times 2 pi over 3 is in the second quadrant, and the sign is positive in the second quadrant, and the value of the sign at 2 pi over 3 is square root of 3 over 2. We can multiply that across and we'll end up getting 3 times the square root of 3. So the rectangular coordinate x comma y, that it represents the same point as 6 comma 2 pi over 3 in polar coordinates, is -3 comma 3 times the square root of 3. Now, I don't have polar graphing paper to match, but at the very least I can see that this ordered pair is in the same quadrant as where the polar coordinate pair is. Find the polar coordinates for the point that has rectangular coordinates 3 times the square root of 3, comma, -3, with our positive and theta between 0 and 2 pi, where 0 can be included. Now, to get polar coordinates, we use the formula r squared equals x squared plus y squared. The x is given as 3 times the square root of 3. We square that, plus the y is -3 squared. So 3 times 3 is 9. The square root of 3 squared is 3. So I'll have 9 times 3 plus -3 times -3 is 9. Oh, nice. So we're going to have 27 plus 9, which is 36. So this tells us that r is equal to plus or minus 6. However, the instructions say find it for positive. So we'll use r equals 6. Now let's look for the theta. The theta is defined, or we get it by saying tan theta is equal to, and it will be y over x. So in this instance, the y is negative 3 over the x, which is 3 times the square root of 3. We can simplify it a little bit, and that'll give us negative 1 over the square root of 3. So we're asking what theta for tangent gives us negative 1 over the square root of 3. And we want this so that, let's see, tangent, we'll do all students take calculus, and we need the tangent to be negative, so it needs to either be a value that corresponds to the theta in the second or in the fourth quadrant. And since r has to be positive, we need the theta to be in the fourth quadrant. That will give us 11 pi over 6. Let's check. We do polar axes, or polar axis, and we go in the counterclockwise direction, 11 pi over 6 units, and then do the r length of 6. It puts us in the right quadrant. So the polar coordinates for this point is going to be r comma theta is, r is positive 6, and the theta is 11 pi over 6. Roman numeral 3, polar equations. To convert an equation from rectangular to polar coordinates, simply replace x with r cosine theta and y with r sine theta, and then simplify. Express the equation x squared plus y squared equals 16 in polar form. We will simply replace x with r cosine theta and y with r sine theta. So x becomes r cosine theta squared plus y becomes r sine theta squared equals 16. Let's square. So you get r squared, then cosine squared theta plus r squared sine squared theta equals 16. We can factor out r squared, and we get cosine squared plus sine squared theta equals 16. R squared times cosine squared theta plus sine squared theta, that's a Pythagorean identity, that's equal to 1, and that's equal to 16. And so we have r squared equals 16. We can also simplify it to r equals 4. X squared plus y squared equals 16 is a circle centered at the origin with a radius of 4. And in polar form, we just write r equals 4.